Welcome back. I'm assuming you all press play immediately on the next video. So well done. So this is where we got up to. Now, how do we actually work out this number? Well, this is where we now need some squared paper. Okay, this is where we actually need some squared paper because there is actually a little formula, a little way of working out what the gradient of a line is, and it's all to do with how far up it goes. And how far along it goes. So let me show you what I mean. So here I've got some squared paper, and I'm going to go one along, one up, one along, one up, one along, one up, and of course I can't actually change this now because otherwise it wouldn't be one straight line. I can't now all of a sudden go one along, five up, for example, because I'd introduce a little angle, wouldn't I? So once I've actually started drawing a straight line, I've got to keep going in that direction. So let me just do that. So this is literally something that's just going like that. Now, what is the gradient of this line? Well, there's a formula. It's one of the most important formulas for GCSE maths. You should start to learn it now. Okay. And I'm going to summarize it really, really simply here. It's how far up divided by how far along. It's how far up vertically divided by how far along horizontally. This along is always left to right. Okay, so the along is always positive. Left to right. Okay, so what do I actually mean? Well, this went one along, one up. So in this question, I could say, well, it was one along, one up. So the up number is 1 and the along number is 1. So the gradient for me in this question is the 1 up on the top and the 1 along on the bottom, and 1 divided by 1 is just 1. So this line here that kind of goes at I guess that's a 45-degree angle, isn't it? The one that goes literally through the diagonal of all these squares, that has a gradient of 1. What that means is it's going the same amount along as it is up. And there was nothing special about drawing a little triangle there. This is a little right angled triangle I've drawn. I could draw it a little bit bigger, and I'm going to actually get the same answer. So let's start it here, because you can start it wherever, because the straight line, well, it's a straight line, so it repeats itself all the time, right? Because it's a straight line. So you can start it wherever. Let's say we go 3 along. Well, when I do 3 along, how far up do I go? Well, I go 3 up, don't I? Otherwise, I'm not back on the line. So it was 3 along and 3 up. So my gradient is also, wouldn't it be embarrassing, right, if we got a different answer? Of course, hopefully you can see we get the same answer. The up number is 3 and the along number is 3, and 3 divided by 3 is also 1. So it doesn't matter how big you draw these little triangles. Now, all these triangles are for is to say how far along horizontally, left to right, how far up vertically to get back onto that straight line. And then those two numbers, you do a division, and that gives you the gradient, tells you how steep it is. So let me do another example. I'll do a steeper line this time. So this time, I'm going to go 1 along, 2 up, 1 along, 2 up, 1 along, 2 up. And if I do this, I get a straight line that looks like this. Now this is steeper than this line up here. Okay, it's steeper than this line here. But what is its gradient? What is its gradient? Well, let's have a look. So this time, let's say I went 2 along. How far up is it? 4. Okay. So the gradient is the up number, which is 4, divided by the along number, which is 2. Now, if you're sat there a bit confused, thinking like, where did the 4 and 2 come from? You get to pick this. You get to choose. Like, you could have gone 1 along and 2 up if you'd preferred, and then it would have been 2 divided by 1. You could also go 3 along and 6 up, or 4 along and 8 up, or 100 along and 200 up. Okay, there's nothing special about the up and along numbers that you pick. What's important is however far along you choose, you have to now go up till you get back onto that straight line. That's important. So I chose to go 2 along because you can make that choice, right? You can choose that. So I chose to go 2 along, which meant I had to go 4 up. 4 divided by 2 is 2. So that line there has a gradient of 2. I'll do one more and then we'll have a look at some Hegarty questions, okay? So, oh, I need my squared paper. There we go. Let's do this one. This time I'm going to go 1 along and 3 down, 1 along, 3 down, 1 along, 3 down. Okay, like this. So that's a steep line. What sort of gradient does it have? So it's going downhill this time. So it's got a negative gradient. So the number that I end up writing is going to be a minus number. I can also guarantee that I'm going to get a minus number if I use my little formula and remember the along. I try to make sure that I keep that being positive, right? Because I can always go left to right, okay? So anyway, let's write the little formula down. Gradient is the up over the along. How far along should we go this time? So someone might say 7, or someone might say 2, like we did before. I'm going to pick 3. Well done if at home you guessed 3. It's totally, you can just make, like, do any, right? You can just do any. I could have done 1, right? If I do 1 along, I go 3 down, right? Fine. I'm going to go 3 along though, so here we go. 3 along. Now that was from left to right, so I'm gonna write 3 as in like positive 3. But this time the up number, well, it's not going up, is it? But I have to put a number of how far up I've gone. So this is where it's a little bit silly, but actually a good way of thinking about it. If I go down, I've actually gone a negative amount up. So let me say that again. If I go down, I've actually gone a negative amount up. So minus up is really down. So since I've gone 9 down, that's negative 9 up. So I'll say that one more time. 9 down is the same thing as negative 9 up. Of course, you don't speak like that when you're actually talking about something practical in the, just in the real world. You don't. Oh yeah, it's two meters down there. You don't say negative 2 meters up there, do you? But in this situation, it's fine. Okay, so I'm going to put negative 9 as my up number because I'm actually going down, right? So negative 9 divided by 3 is negative 3. We've got a negative gradient. It's going down. That's it. So let's have a look at some Hegarty questions now, because I actually think we can pretty much answer most of them. So, assuming it loads, so do quiz. Might have to refresh this. So find the gradient of the line segment between the points 8, 6 and 10, 12. Okay, so I've not actually talked yet And this is why it's useful for me to obviously load up the Hegarty questions, because if I can see them, I can be thinking, all right, well, yeah, actually, I need to mention stuff about coordinates, don't I? Well, it's possible to do this just by thinking about how far along and how far up or down you would have gone. So let's have a think about that. So I've got 1 point, which is 8, 6. And I've got another point, which is 10, 12. So just, even if you do a rough sketch, 8 along and 6 up. So this is literally a rough sketch. You saw how I did that. I've not measured anything here. And then I've got 10. Now what have I actually got to do? I've got to almost double that if I'm even going to do it vaguely accurately. So 10, 12 is up here. And then there's my line. But it's not been drawn accurately. It's not been drawn accurately. I could have actually drawn it accurately with some graph paper. But it would be a good idea to be able to do it roughly, because the numbers could be more complicated, right? You don't want to be drawing these perfectly every single time. So I'm going to try to show you how you do this. Well, ultimately without drawing anything at all. Actually, you can do this without drawing anything. But let me show you with a little rough sketch like this. So the gradient of this line, I need to know the along number, and I need to know the up number. Right, this is what I actually need. So I'll just write this down. So gradient equals up over along. And remember, if it's actually going down, if it's a negative up, that's what you'd have, a negative number. So let's look at the along first. I know it's on the bottom. So we'd usually do in order, we do the numerator then the denominator. But anyway, let's have a look at the along first. So the along is actually, well, you can work it out. How far along is it from 8 to 10? So it's 2 along, right? And actually there's a general formula that we could come up with here. Like if this was 87 and this was 106, what would you do? What would you do with the numbers? Yeah, so you do, you do the big one and then you take away the little one, or you make sure you're at least being consistent in which way round you're doing it, right? You just want to know what this distance is. So I'm going to have 10 take away 8 on the bottom here, which is of course 2. But I'm going to leave it like that for now so you can see where it's come from. And then for the up number, it'll be 12 take away 6. And so what's this? This is 6 over 2, which is 3. So there we go. Now, I would suspect that we'll end up with some which are negative numbers and things like that. So where it gets a bit more complicated because it's got minus numbers in. So I guess what I would do is I would just kind of write down a general formula for you. Okay, so here's the general formula. So your gradient, which is your up over your along, is your difference in the y values divided by the difference in the x values. So if you have two coordinates, x1, y1, and another coordinate, so one coordinate x1, y1, another coordinate x2, y2, the gradient is the two y numbers, the difference between those, and then divided by the difference between two x numbers. So I'll leave that there on the screen and answer a few more questions just using the formula, so you can see how the formula is used. So what goes on the top is 14 take away 6. So 14 take away 6 is 8. So it's 8 on the top. And then on the bottom, Remember, I've got to do it the same way round. So because I did 14 take away 6, I have to do 8 take away 4. Okay, so 8 take away 4 is 4. And what's that? 8 on the top and 4 on the bottom. Of course, you could be writing these things down, right? 8 on the top, 4 on the bottom. 8 divided by 4 is 2. Now, one question which a lot of people would usually end up asking in class is, what if I do it the other way around? Like, what if I did the 4, 6 one, kind of take away the 8, 14 one instead of the way around that I just did it? Well, you can. You can do that. Let's see what happens. So it would be 6 take away 14 on the top. So that's minus 8 on the top. But then what would it be on the bottom? It would be 4 take away 8, which is minus 4. So it would be minus 8 divided by minus 4. And so what ends up happening is it doesn't actually matter which way round you actually do the formula. Because if you ended up with a negative divided by a negative, it would cancel out and just be a positive anyway, right? A negative 8 divided by negative 4 is also equal to 2. Doesn't matter. Okay, so it doesn't actually matter which way round you do it. Of course, it's nicer if you do it with positive numbers, but it doesn't actually matter. I'm just gonna skip until I find one where it's going to be negative. Okay. We could talk about this one just purely because there are some negative numbers in it. So let's do that. So hopefully you've made a note of that. That would have been a good idea to do. You can always go back and pause if you haven't. So I've got 4 minus 4 and I've got 0 minus 12. So the gradient is going to be the difference in the y numbers. So I'm going to have minus 12 take away minus 4. And it's going to be divided by the difference in the x numbers. So 0 take away 4. So this is where it's negative number arithmetic, right? You have to be super careful. When you take away a negative, you're getting more positive, right? You're feeling happier. You go up the number line. So negative 12 take away negative 4, I go up the number line to negative 8. And 0 take away 4 is negative 4. And then a negative divided by a negative is a positive. So there you go. I think I might go on to have a look at another Heggerty task now, just so I can establish what it is I need to do. All right, so actually in that one, maybe it would be a good idea if I really plan the video out better to begin with, but actually I don't mind so much discovering this as I'm recording the video. I actually don't think it matters too much. So in 201, I think all your answers are going to be positive. I mean, maybe not, but the fact that the next one is gradient of a line segment negative suggests that probably most of your answers at least will be positive. So let's just do one of those and see how that works. All right, so again, I'm just going to use the formula that I just talked about, okay? Or you know, you can think of it as a method if you want to. So I've got 2, 2, and I've got 0, 6, okay? So this time, I've got to do 6 take away 2 on the top. So it's the difference in the y numbers on the top. So 6 take away 2. And then on the bottom, I have 0 take away 2. You could do it the other way around. Let me actually show you what that is. So if I did it the other way around, I would have 2 take away 6. So it's this 2 take away 6 on the top. And then 2 take away 0 on the bottom. Let's see if we get the same answer for both. Spoiler alert, we're going to get the same answer. Okay, so 6 take away 2 is 4. 0 take away 2 is minus 2. 2 take away 6, that's minus 4, but 2 take away 0 is 2. So notice how it's just kind of swapped the negative from the bottom to the top. Now when this happens, it doesn't actually change the answer. So these things are actually equal to each other. And they're both equal to negative 2. So there you go. So I'm hopeful that you'd be able to have a go at that as well, if you've understood what we've done. Right, 203. Now, this is actually not so bad. I know you might think, ooh, it's got fractions in it. so it's going to be harder. But actually, it's if you can simplify fractions, then you can actually already do this. So let me just answer this first question on task 203. And you'll see why it's actually, if you can do the other two, you can do this one as well. Okay, so I've got -8, 6, and I've got 3, 7. So remember, I'd be asking how far along is it and how far up is it between these two coordinates. So my gradient is how far up, so I'll do 7 take away 6. And I'll do over how far along. Well, how far is it from 3 to -8? So 3 take away -8. What's the literal distance from -8 up to 3? So this is another good reason why taking away a negative should actually result in something, be like going up the number line, because you should realize the answer, of course, needs to be 11, doesn't it? The distance from -8 to 3 is 11. And 3 take away -8 is indeed 11. So I get 1 on the top and I get 11 on the bottom. Well, there you go. Fraction button. 1, 11. Why has it done that? Pretty sure what I did was right there. 7 take away 6 and 3 take away -8. 7 take away 6 is 1. 3 take away -8 is 11. So I'm wondering if that was just a issue with my browser. But anyway, let's continue this quiz and see what happens. Okay, so I got a slightly different question here. Sorry about that. Technical difficulty. Whatever. I can bring the calculator up on the screen even. So on the calculator, if I had on the top 7 take away 6, and on the bottom 3 take away -8, of course I get an 11th. So I think that was an issue with Hegarty. But anyway, let's see if now that I've refreshed this is going to work. Okay, so here I'm going to have -6, 2, and 4, 3. The gradient is 3 take away 2 and 4 take away -6. So 3 take away 2 is 1 and 4 take away -6 is 10. So this had better work basically, otherwise I'm not going to be pleased. Aha, so I really think that was just a problem in that other question, so let's not worry too much about that. Okay, and the fact that it says give your answer in its simplest form just means sometimes you're going to get an answer here that simplifies. Like, fine. And you could also get a negative fraction. So you can just put a minus sign. Let me make sure I'm typing. You could put a minus sign and then your fraction button. And then you'd be able to put a minus fraction in. Okay? So that's how you do that one. So this is actually just like what you've been doing, but the answer doesn't simplify down to a whole number. Okay, it's going to be a fraction. It just wants the gradient. So based on the picture, can you work out what the gradient is? So, no, I don't want to set the task. I want to... There we go, right. So what you want to try and do is you want to try to find like whole number coordinates so that you can just kind of go however many along, however many up, so it's dead easy. So for example, here's a whole number coordinate and there's a whole number coordinate, and so I go 1 along and 2 up. I guess I also go 2 along and 4 up. You can do it however you want. The answer in this situation is going to be 2, because the up divided by the along, 2 divided by 1, 4 divided by 2, both give you 2. So I might skip until we get some harder questions, okay? Oh, maybe I just want to say something about this. So be careful of the scale. So this is 2 up and 2 along. Do you see that? It's going from 0 up to 2 up, but it's going from 2 along to 4 along. Because the scale is a little bit different, you have to be really careful. What I'm actually starting to think is I might end this video here and record one more video where I actually start with this task and finish it by talking about task 205. I think this is actually 3 videos. Okay, so well done if you've gotten this far. There will be one more video. I'll try to keep it short, but I'm going to end this video here. The next one, I'll continue to talk about this and also talk about task 205.